Alright guys, this is topic 16, discrete random variables. In this, according to the description, I'm going to be covering including expectation and using tables to solve problems where probability adds to 1. I'm going to be covering examples 3 and 5 on page 626, and before we hit that, we're going to hit some definitions. Before going into the examples, it's important to know the difference between a random variable and a discrete random variable. So a random variable represents, in number form, the possible outcomes which could occur for some random experiment. While a discrete random variable, x, has a set of distinct possible values you will consider, and you will consider only a certain finite number of outcomes. So what they mean by this is that a random variable could potentially have an infinite number of outcomes, while a discrete random variable has a more precise set of outcomes. There's only a certain number of possible values, and after that, there are no other possible values that could occur with in the sample space. So for example, an example of a discrete random variable is a number of heads in 4 flips of a coin. So since this is a discrete example, the possibilities can only be 0, 1, 2, 3, or 4. You can't say 5 because you're only flipping the coin 4 times. So going into problem 3, a random variable x has the probability distribution function px described in the table. They want you to find k, that's part A. So we have this table, and in order to find k, basically what you have to do is you have to add up the bottom, pretty much y value number is the p of x. So you add up 0.1 plus 0.3 plus 0.45 plus 0.1 plus k, and you make that equal to 1. Now, why do you make it equal to 1? Well, consider the y values. They're almost like percentages. Everything can only add up to, let's say, 100%, but in this case, it's not percentages, they're decimals. So to get 0 for x, the probability is 0.1. To get 1, 0.3. To get 2, so let's say the probability of picking 2 marbles or whatever is 0.45, and the probability of picking 3 marbles is 0.1. So they just want to know what the probability is of, if you're doing marbles, what that 4th marble is. So treating it, the best way is, like I said, to treat it like a percentage, and you want all these to add up to 100%. Or, in this case, 1. So once you do the math, you get 0.05, which is your answer for k, which brings us into part B. Find the probability that x is greater than or equal to 3. So what does this mean? If you have the greater than or equal to sign, it means that they want you to find the probability that x is 3 or x is 4. So pretty much what you have to do is to find the probability that x is greater than or equal to 3. They want you to add up the probability that x could be 3 plus the probability that x could be 4. So that's 0.1 plus 0.05, which is k, because we found that out here. And therefore your answer is 0.15. So lastly, part C is find the expectation for the distribution. Now, in order to find the expectation, you have to do one thing, pretty much. It's pretty basic. You have to just multiply the event, or the x value, by the p of x value. So that brings us to 0 times 0.1 plus 1 times 0.3 plus 2 times 0.45 plus 3 times 0.1 plus 4 times 0.05. And if you add that up, you get that the expectation is 1.7. Moving on to example 5. 3 green balls and 2 yellow balls are placed in a hat. 2 balls are randomly drawn without replacement. Let x be the number of green balls drawn. So they want us to find the probability for part A, part I, that x is equal to 0. So if x is the number of green balls drawn, they want us to find the probability that 0 green balls have been drawn out of the 3 green balls and 2 yellow balls. So if no green balls are drawn, what does that mean? Well, the only other balls in there are yellow. So that means that a yellow ball had to be drawn because there's no other possibility that could occur. So the probability of drawing a yellow ball, therefore, is 2 out of 5 because there's 2 yellow balls and 3 green balls, and 3 plus 2 equals 5. The probability of drawing another yellow without replacement. So what does that mean? Well, the probability of drawing another yellow without replacement means that there's one less marble in the bag, which is why our denominator goes down from 5 to 4, because there are less marbles that can be chosen. Now there's only 4 marbles. Since a green marble was drawn, that means, a yellow marble, this is the probability of a yellow being drawn. We do the same thing for the numerator. We subtract 1 from the numerator, since this is talking about the yellow balls, and we get 1 out of 4, or 1/4. So, to find the probability that x equals 0, looking at the big picture, what we have to do is we have to multiply this fraction by this fraction. Because it said 2 balls are randomly drawn without replacement, so even though maybe it kind of sounded like that at first, the problem actually didn't end here. The problem still goes on here, and you need this final step, which is extremely important, that you multiply the both together. Because usually when you are finding the probability of this and that, the and usually refers to multiplication. So that's why you have to multiply in this case. So part 2, they want you to see 2 balls are randomly drawn without replacement. They want to know the probability of 1 green ball being drawn. So the probability of getting 1 green ball is originally 3 out of 5. And then moving on to, let's see, 3, they want to know what's the probability that 2 green balls would be drawn. So trial 1, the probability for the draw 1 of drawing a green is 3/5, but trial 2, it's only 2/4. So once again, what they want you to do is they want you to multiply these fractions together to get the answer, and you can simplify it and get 3/10. Also, they ask for the expectation. I've already explained that. I can't remember if it was in this one. Oh, yes, it was in this video. So if you want to know how to do that, you can just refer to the previous part and apply that to model it. Thanks, guys. Good luck on the midterm.